Good evening, everybody. On the behalf of JC Bose,
Is my voice clear?
yes, sir, your voice is clear.
Good.
On the behalf of JC Bose University of Science and Technology, YMCA, Faridabad, I welcome our today's speaker, Sri Anil Kaul. Anil Kaul is a postgraduate in production engineering and automobile from Delhi College of Engineering, MIT, and YMCA Institute of Engineering, and has also privileged to have studied management at IIMK. He is having over 34 years of rich progressive experience in automotive sector with specific focus on business development, strategic planning, plant operations, production engineering, process re-engineering, project management, supply chain management with reputed automobile organization in India. He has conducted session at CII and ACMA Forum for Energy Management, EMS and TS 16949 besides conducting workshop on lean manufacturing concepts for various organizations as an instructor. Prior to joining Auto Ignition, he was managing director at Value Engine Electrical System India Limited, Pune. His previous experience includes working at various reputed organizations such as Director India Operations at International Automotive Components, Pune, COO Tata Autocom System Limited, Interior and Plastic Division at Pune, Vision India, Chennai, Hero Motors, Ghaziabad, and he has worked at and both trained at various Ford plants in North America and UK. Now we welcome Anil Polji, and I request him to enlighten us with his valuable thoughts.
Thank you, Nikhil, for introducing me to the esteemed audience. Good evening and good morning to some of you who might be joining from abroad. And my endeavor is going to be taking you through what we practice in industry, which is energy conservation management and sustainability. This was the mandate given to me that I should be uh, taking the audience through across on this topic, so that they are able to understand what is happening in the industry and what are the practices. So we're going to have a discussion. I'll take you through some basic concepts which are on energy, and then we will go through how do we do the energy audits, and then what some practical examples what we have done in the industry. Am I clear, Nikhil?
Yes, sir, you are very much clear.
Very good. So we move on to the slide number 2, which is the objective was to enable and understand the energy data of industries in terms of analyzing the data, what industry has, understanding and accounting for it, and doing the energy balancing. It was also to understand how the energy audit and methodologies are there through which we do the energy savings, to understand the utilization of available resources in optimal ways. We've been going through the optimization techniques ourselves via recently, and to understand the minimization of environmental effects. The outcome of this is to understand, as I said, the accounting of energy and balancing of energy, and to suggest methodologies of energy savings. So with this preamble, we move on to slide number 3. Slide number 3, we just recapitulate ourselves. What is energy? I don't have to teach you all, guys, but still, just to recapitulate, energy is the capacity of doing or performing a work of a physical system. There are different forms of energy, which is we all understand. Heat is one form of energy. kinetic or mechanical energy, which we'll see in subsequent slides, is another form of energy. Light is yet another form of energy. We have potential energy, we have electrical energy, we have different forms of energy. And just to understand a little bit, we all have known law of conservation of energy or law of conservation of mass, which we have gone through since our school science days, that the total energy of the system remains constant, and the energy may transform from one form to another, but eventually it remains, the total energy of the system remains constant. One would take an example of, I don't know how many of you have played billiards, but if you see, it's a simple example of understanding. If you play billiards and hit a ball, a white ball to the colored ball, or play snooker, and you might see that when you hit a ball to another ball, the direction of the ball which is in rest changes, and it results in transforming the kinetic energy of one ball to the kinetic energy of another ball. Also, at the same time, you hit a tick sound when the two balls collide, so it is transforming into sound energy. And perhaps which we may not be able to visualize, or which we may not be able to see it at the point of collision, there will be some sort of a heat energy which also will be created because of the collision. We move on to the next slide, please, which is slide number 4. This slide tells us there are different forms of energy, what types of energy, what we have seen and we have talked about in the previous slide. And if we see, it's divided into kinetic energy and potential energy. And kinetic energy on the left side, energy of motion, when the particles or the objects are in motion. You see the man running, so he's having a kinetic energy. Then you have mechanical energy. You can see it from the symbol over there, a man riding a bicycle, and the bicycle is in motion, and that's a mechanical energy what we perceive. Electrical energy, it's in the form of the electrical, mostly the motion of electrons or ions and electrons, and positive charges. Thermal energy, which is part of the heat energy, which can be due to vibrations or movement of particles. Radiant energy, which is mainly because of light, electromagnetic energy, and which can transport in terms of transverse waves, or you can have longitudinal waves as well. And lastly, the sound energy is also a form of kinetic energy. If you see on the right side, the potential energy is there. It's generally stored, and it's in the form of chemical energy, which you see in the cells or batteries. Then you have nuclear energy, atoms and nuclei in constant motion, and which when collision happens, it gets transformed, and you can see it in the form of thermal energy and light energy emitting out when the collision of electrons and neutrons happen to the atoms. Then you have gravitational energy, which is due to the height. We'll see in the subsequent slide. And there is elastic energy, which could be in the form of easy depiction what we have springs. When we compress the springs, normal compression spring or an expansion spring, if you expand it, and you can see the form of energy which is stored. Having understood the types of energy, we'll go to the next slide, slide number 5, please. It's a simple depiction of understanding of kinetic energy and potential energy. And we all have studied in the basic physics of 11th class. The kinetic energy, the formulas are very clear, the picture is very clear, and it gives us some understanding of that if we pick up an object and leave it onto the ground, and at when we are picking it up and having it in the hands, there is a potential energy, even if it is a ball. And then when just we leave it, it gets converted into, the ball goes down, it gets converted into kinetic energy and potential energy, the sum of it. And at the bottom, when it hits the Mother Earth, it's having the total kinetic energy. So it's just a representation of the energy getting transformed from total potential energy to total kinetic energy. We move on to the slide number 6, which is the different form of energy which is relevant to us. Now, relevant to us in these examples, what we see is electrical energy. Whenever there is a current flowing, uh, this is an electrical energy which we are talking about and which we comprehend in daily life. Then you have light energy. This is anything which is luminous in nature. You can see it from the standpoint of light bulb or candles or batteries, what we have, uh, which which emits lights. Then sound energy, anything which emits sounds. It could be our vocal cords when I'm speaking. It could be speakers or musical instruments. That is the part of sound energy. Thermal and heat energy, which we all know. Any object which is, I mean, it can be construed in terms of an object which is hotter is having some amount of thermal energy, and which can be construed by way of temperature. The higher the temperature, the more heat energy it possesses. Similarly, for gravitational potential, you have gravitational field, and due to that, any body can possess potential energy. The higher it goes, the more potential energy it has. Then moving on, chemical energy, which we have seen in terms of cells, what we have in the normal life, and we use the chemical reaction inside the cells to generate the electrical energy, converting chemical energy into electrical energy. Kinetic energy we have seen enough, and similarly in the springs we've talked about having the elastic energy. Now moving on to this is again the same thing, which is in the form of different objects, what we see normally. I'll not go into it. We've talked about the law of conservation of energy. So we will move on to the slide number 8, which is important from the definition of energy management standpoint. The strategy of adjusting and optimizing our systems and procedures to reduce energy requirements per unit output is important. And while we are holding this as constant, reducing the total cost of producing the output from these systems. Now, this is a little complicated statement which you might think it um, on an ordinary way. But what we are trying to say in this is that we have total re energy requirements in any plant operations, which is used in different systems and different procedures. Our constant endeavor is to reduce the costs so that we improve the profitability. And I'll tell you in one of the slides subsequently wherein why it's important uh, to do that. Now, to understand that context, it can be construed in two methodologies. The management of energy systems, though it goes through the PDCA cycle, however, it needs to be understood in connotation with the two methodologies by which we control or we act in the plant operations. One of the one of the areas which gets addressed is through the managerial address on the energy needs of the organization. The important thing is to plan and policy deploy what are our energy needs and targets for. It could be based on example is annual requirements, it could be based on long-term requirements, and once that is part of your annual operating plans, or these are part of your long-term plans. So the managerial importance is that the management of any business operations is first to plan for it, which is to policy deploy, make the goals, make the targets, whether it is long term, whether it is short term, and provide the resources for doing so. And this gets, once you have planned for it, then what you do is for the deployment, you have to train your resources, you need to communicate to the entire organization, and you need to have in control equipment and which means systems and processes to understand where are we going in terms of our plan, our targets. And for that we require check. uh, we do the corrective and preventive actions, we do the conducted through the internal audits, which we will subsequently see. And then if our plans are going haywire, or are they on track, can we improve the efficiency, or can we improve it better than the target? That is taken through the action point of view or act point of view. And that is where management review happens. And then they see where are we as against the target, and what do we need to do in order to either improve or get more yield. So this is the managerial responsibility of the energy management. On the other side, when you see the technical part of it, uh, the engineer level responsibility is, if I may say so, is to collect the data. This data is needed to be collected, assessed properly, and presented to the management so that they can take a call on that. They for them, the do part of it is also how much are they purchasing in terms of energy annually and in long term. What are the methods of purchasing they do? What is the design methodology of what is the design methodology adopted? For example, you can have different sets of motors which you require for the plant. Is there uh, specifications of the motor uh, mm, more than what is required or less than what is required? That needs to be adequately assessed. And similarly, the what sort of projects need to be done, that gets evolved once you do certain audits, which we'll see in subsequent slides. And then you do the verification of these. So all this is done in the do part of the technical assessment. And then you have various mechanisms to monitor and measure what's going on in terms of energy needs. Once this is done, and then you see the system performance, and you try to see the optimal performance of the system. Can we optimize it further, or can we do something else in order to contribute towards the profitability of the organization through energy management, what's happening at the plant level? Having understood the energy management, we go to the next slide, slide number 9, please. This slide, mainly we are able to understand the different forms of energy. For example, we have renewable energy, which is available to us in terms of hydro, geothermal, which you have seen, which you have heard the speakers before me, or they were talking about these renewable energy resources, what we can utilize to cater to our energy needs entirely, in terms of solar, biodiesel, biomass. And then you have the second category in this pyramid. If you see the energy efficiency, there are things by which we can, which we, if we adopt these mechanisms, which we will be able to improve our efficiency, uh, we improve our efficiency better than what we are doing once we do the current state mapping. And it can be in the form of electricity, it can be in the form of hot water requirements, heating requirements, refrigeration and air conditioning, and your water recycling mechanism. And then there is a conservation part of it. If you see at the bottom of the pyramid, the conservation part of it is the energy efficient buildings. How do we conserve energy in terms of what we get and what we retain, and in terms of recycling the water. Once we have heated up the water, how do we recycle it, how do we make use the waste heat recovery, etc. And similarly, this happens in case of transports. In case of when we are using the alternate transports of e-vehicles, which is the in thing today, e-buses, e-cars, etc. So having understood that, once we move on to what is for the slide number 10, which is the Bureau of Energy Efficiency. Now, Government of India uh, thought of in 2001 to bring in Energy Conservation Act, and this act was to address the what sort of an energy intensive industry norms are required. There are different types of industries, all of you know about it, and the different industries have different usage patterns and different requirements. So they thought we should bring in the norms for energy intensive industries. We should have some standardization and labeling. We should be providing the building codes for energy conservation. Of course, it has to be met with what is the demand side of the management, and what sort of a certification of energy professionals they would provide. And they used to conduct the exams for the energy auditors and energy managers. This uh, uh, this thing was also started, this initiative was also started by Government of India through Bureau of Energy Efficiency. And this act came into establishment in March 2002. They implemented this regulatory and promotional functions of Energy Conservation Act, which was deployed. And they came out with the methodologies to reduce the energy intensity for our country's needs. And this was also deployed to the different states through different agencies, which uh, states on their own developed, and they had their own mechanisms to enforce them and to make the people and industry aware of it. Having understood what the government was expected and what government did for that, we move on to the next slide, which is slide number 11. In this, we're talking about this site of, I just thought I'll put it, there is a site on Bureau of Energy Efficiency, which gives you all these details, what we've talked about, and what are the new requirements, and what are the requirements for different equipment, and which we will see in slide number 12. Uh, Slide number 12, in fact, we will go to first the slide number 13, and then we'll come back to slide number 12, please. In the slide number 13, which you see, what came out of BEE was the Bureau of Energy Efficiency. They said that there are certain equipment for the normal consumer durable use, which is mandatory for the appliance manufacturers to have. For example, room air conditioners, refrigerators, fluorescent lamps, distribution transformers, or room air conditioners. direct cooled refrigerators, all these equipment are mandatory to have the star rating to be stated on them. And on the voluntary side, they said on you can put them on the motors, the pumps, the fans, the stoves, the washing machines, and you have plethora of equipment which are voluntary in nature for putting up the star rating. And having understood where is it required mandatorily, because this was the step towards uh, making industry aware that these are the energy efficient equipment which you are selling, and you have a gradation so that you are able to tell between the different manufacturers that what star rating is. Suppose Philips is 5 star, or LG is 5 star, and who else? There could be a local manufacturer who is providing the equipment with 3 star, etc. So having graded that, we understand why was it required. We'll go to the slide number 12, please. Slide number 12, what will tell us something about, on the right side, you will be able to see this is the label which was provided, for example, for the uh, air conditioner. And if you see in the right side of it, you will see that you have 3.10 as EER, which is watt by watt, which means energy efficiency ratio. And in current times, what BE has upgraded, it has been upgraded to ISEER, which is Indian Seasonal Energy Efficiency Ratio. So this has been upgraded, and through the years from 2001, this has been constantly getting upgraded, and the stars are getting improved from. Some of the manufacturers were at 2.7 star, and then it has got continuously moving up and moving towards 5. And why was it required? This was primarily required in order to understand the variation between the consumption of products by different manufacturers. Because if you was AC manufactured by Samsung or by LG versus uh, done manufactured by Voltas, there could be variation in energy consumption. So they gave some sort of a labeling and star rating to these manufacturers so that they can tell that our equipment is better in terms of energy consumption. And often it was not easily understandable, because nobody as a common man would understand this. So they came out with the idea of putting a label onto the equipment so that people are able to easily correlate to the efficiency of this product. And also this competitiveness would lead to uh, doing away with the inefficient equipment or appliances within the marketplace. Having started off this, there is a little bit to the history and success. Primarily this was started off in Poland in way back in 1962, and then it got cascaded to North America and to Europe and eastern part of the globe, which is Thailand, Japan, and the South America, which is Brazil. So this was just to give you an idea of about the why do we want energy management, and why do we require energy efficient equipment in order to cater to the needs of energy, which of course there was an old saying which I wanted to share with you all, that energy saved, or 1 unit of energy saved, is corresponds to 1 unit of energy not to be produced. So that's the bottom line and importance of energy management. Having understood this part of it, we can go to the energy audit side of our understanding. What are energy audits? If we go to the slide number 15, we start with what is an energy audit. See, as per Indian Energy Conservation Act, which we talked about in previous slides, it's about the act has defined it's about the verification, monitoring, and analysis of use of energy, including submission of technical report containing recommendations of improving energy efficiency with cost benefit analysis and action plan to reduce energy consumption. So primarily, if you sum it up, what it talks about is in any plant operations or in any business operations which is working towards manufacturing of products to be supplied to marketplace for domestic or industrial consumption use, we need to be doing the verification and analysis of energy uh, for that particular plant, do a technical report, and then deploy methodologies to improve energy efficiency. Of course, the bottom line has to be it has to have a benefit to the business, and it has to have plans to reduce energy. Now, having understood what is required as an energy audit definition, we go to the slide number 16, wherein we understand what are the objectives of energy management system and how do we attain that. So we have to ask ourselves 5 questions that whenever we go through into our plant, how much of the energy is consumed. When I'm saying whenever we are talking about, since mostly we talk about the plant operations, but it can be also about the buildings, it can be about the malls, it can be about the institutions, it can be in any form of an enterprise where the energy consumption is significant. So from that standpoint, when I'm saying plant, you can take it as it's for the entire businesses where consumption is significant. So the questions which we are asking is how much energy is consumed, how is the energy consumed, in which form, where is the energy consumed, when is the energy consumed, and what is the quality of the energy consumed. So whenever we do understanding this, our objective is to answer and collect answers to these questions when we are doing those audits. We move on to slide number 17, which is when there is a need of energy audit. Why there is a need of energy audit, I have explained you in my previous slide. And one of the important aspects also to understand when we are analyzing is that there are 3 top operating expenses in any business, in manufacturing business particularly. I'm always referring in parlance with manufacturing because that's the major consumer of energy in different forms. So the 3 top operating expenses, when you analyze the P&L of any manufacturing company, you will see one of the important factors is electrical and thermal energy expense. And besides labor and material cost, of course, is extremely important because that almost weighs, depending on what the business operations are, between 40% to sometimes it goes as high as 70%. But use of energy is also as significant, between 3% to 10%, depending on what business you are in. So energy is one of the very important factors, and it also emerges as the top ranker in terms of reduction. Because any organization, whenever it looks towards that, wherever it has to be reducing costs, one of the important parameters is how do we reduce the energy cost, because that's going to be perennial in nature. That is going to be consistent in nature, that you are going to consistently use the energy resource. So primary objective of these is to reduce our energy consumption per unit of the output product. It could be, for example, in automotive industry, and they try to see that per unit of car produced or per unit of tractor produced, how much is the energy consumption per unit of product output which they are marketing it to the marketplace, and they have to keep this operating cost low. So this also provides us the benchmark in order to understand with respect to the different companies in the industry. For example, tractor industry, say it is X per unit of tractor. For one company, it might be X, or another company, it might be X plus delta X. So that is what we need to understand as a benchmark and try to optimize and come to a situation wherein we are the lowest cost producer. Example I'll give you, at one point of time, uh, Hindalco, which is the Hindustan Aluminium, which produces aluminium, it was having the lowest cost per ton of energy consumption to produce 1 ton of aluminium. So in worldwide, so that is where the benchmarking comes into picture. So how good are you with respect to your peer companies within India and globally? Having understood this, we move on to the slide number 18. So how do we conduct these audits? What type of audits are required to conduct? So mainly there are three types of audits which get into existence, or which come into deployment. One is the preliminary energy audit, the second is the targeted energy audit, and third is the detailed energy audit. We'll go through one by one all these three audits. So slide number 19 will tell us the preliminary energy audit. Now, what is preliminary energy audit? It's an audit for which normally you go to any company and you do a preliminary assessment. You understand what are the manufacturing processes, what are the energy requirements, what are the different forms of energy being utilized, and this you tend to do it in a span of say 1 to 3 days, and you should be able to cover approximately 70% of the energy requirements of the company, understanding it, whether they're predominantly requiring electrical energy. For example, blast furnace, they will require a huge amount of electrical energy. Requirements are there for blast furnace, and or they are how are they doing in terms of wastage of energy, how are they doing in terms of improvements, and what are their reference points. All these things are done in the preliminary energy audits. So this gives you some sort of a dipstick, and this still tells you some sort of that what sort of a data we have available for doing a uh, preliminary, I mean, doing the total audit in future. So this is a quick survey for understanding the energy requirements and energy audit requirements for a company. Then we go on to the next is slide number 20, which is the targeted energy audits. Having understood quickly what the type of industry is, for example, fertilizer plant, it has got a huge energy requirements, and you have different sub processes involved where you are requiring to do different processes to create urea, and those processes you have big P&I pressure and industrial equipment, wherein the chemical processes which the different chemicals go through, they are subjected to different pressures, and they're different, they're subjected to different temperatures. Then you go through mixing, then you go to different stages in wherein you do the distillations, cracking, etc. There's a lot of processes involved into. So having understood that, then you have to do the, for example, if a company wants, they can do the targeted energy audits. For example, if they through their preliminary audit are able to understand that we got a bad boiler system. We want to target only boiler system, or we want to do only lighting system, or we want to do compressed air system. Reason being, there many times what happens is budget allocation becomes a challenge, and what we want to do having gone through. So sometimes the management takes a decision, what we studied in the slide when we were doing the total energy management. There the management takes a call that, okay, we want to do targeted areas of energy audit and understand what can we do to improve these targeted areas. So that's where that's how you do the targeted energy audits. So it is for the targeted systems in an organization. Moving on, we move to slide number 21, which is the detailed energy audit. Now, having understood the previous two, the detailed energy audit, of course, is an audit which will go into the details of the audit which we do for energy management for different subsystems. And what happens is you also get into, for example, uh, for a system, if you have 10 kilowatt motor, induction motor required, is it really required for 10 kilowatt? Can we do it with an 8 kilowatt motor? If it is available as a standard product with some manufacturer, of course, its efficiency has to be looked into. From that standpoint, you get into the engineering part of it also, to understand whether the system is over designed, or is it adequate, or is it performing suboptimally. Can we improve its performance by improving the efficiency? So that's the detailing what you do in terms of detailed energy audits, and it covers approximately 95% of the energy of the whole plant requirements. So and of course we'll see it in first subsequent slides. There are methodologies by which we can um, make the detailed assessment through different instruments what we are using, and understand and compute the total energy requirements. Then this is some sort of a current state mapping what we will do in the detailed energy audit, which means current state mapping means we will understand what is the system performing currently as of now, and based on that we will identify the opportunities for improvements, OFIs, and that is where we will then make a plan to attack those opportunities and how we improve, and then we will see subsequently. So this is what basically the detailed energy audit is all about. Having understood this, we move on to the scope of work for detailed energy audit. This is what I have explained you. We go through and understand even the electricity bills, we understand the contract demand, how much is it. Many a times what happens is, in when we have applied for the connections for the plant, we ask for some contract demand. So say in my case, that's why I'm giving you. So we do a contract demand of 1000 kVA or something, but our requirement currently is going only at 500. So is there a need for having to go for contract demand of such a high capacity? May be worth looking into, because once you do a contract demand with the electricity board, they will charge you consistently month after month for the same contract demand, which may not be required. And also what happens is, when the demand is high and you have contract demand with the electricity company or electricity board, they have committed to you, but there could be some other company which requires this the energy. However, they have not been given because they don't have surplus, and you have blocked this, and once you have blocked this and you are not using it, it is a sin for the society. So from that standpoint, it is important to understand and assess the electricity bills, go into the detail, understand contract demand, understand where are we in terms of power factor, how do we improve it if we are doing badly, and how do we do make up through capacitor banks, etc., so that our power factor improves and we are able to be more energy efficient. These are the ways and methods by which you can improve. Similarly, having understood one that how do we do the energy audits in details, we go through the electrical systems, the networking, what you have, what are the losses in the system, what are the operating patterns, how are we doing in terms of energy management, in terms of how is the distribution of the power happening within the company. All that we go through the electrical system network, we study the motors and pumps loading, we study the air conditioning plants, we shall study the cooling tower, what is the efficiency, for example, in terms of cooling towers, that what is the temperature differential what we are expecting. Is the cooling tower only able to give you 2-degree advantage? Normally a cooling tower should be able to give you a differential of around 5 degrees, but is it doing badly? Is it not having the is it performing suboptimally? And what should we do? How should we uh, uh, look into the parameters like approach of the water which is getting dissipated in terms of atomized air, and so that heat exchange is taking place properly, what is its effectiveness and all that. So we go into the detailed in each and every equipment. And what do we do, what is our specific energy consumption in terms of air conditioning plants, kilowatt per ton of refrigeration, and this we study for all compressors, chillers, etc. So all this is to understand that where are we lacking, and what where are the opportunities for improvement. Having understood this in detail, we have further in slide 23 in terms of boilers, turbines, air compressors, you name the equipment, and there you will find the opportunities of improvement will be there in terms of waste recoveries, waste heat recoveries for condensers or boilers. For boilers, it will be flue gas, which will be important to understand in terms of efficiency. So all these equipment what are there in the plant and which are dealing with different forms of energy, whether it is electrical, whether it is gaseous, whether it is turbines, whether it is air compressors, you name the energy, and there you will find it in different forms or different equipment being dealt with in your plants. So having understood all these equipment, so you can imagine how much amount of potential is there to improve uh, the efficiency of the equipment in the plants. Having understood this, we go to the slide number 24. Then how do you do, what are the instruments which are required to measure the current state mapping of different energies, and the measurements what we get, so that we understand where are we in terms of current state mapping, where are we, for example, are we drawing the right amount of for example, you can see the kVA meter or the kW meter on the left side below, or you have a power factor meter, so you're able to measure through these meters, able to understand whether we are at a power factor of 0.95 or we are at a power factor of 0.99. So if we are at 95, so what do we need to do? Do we need to do add capacitor banks or capacitors in the capacitor bank, so that we are able to we improve our power factor, and thus our bill gets reduced. So similarly, you have different meters on left side. You can see the cathode ray oscilloscope also, and you have the instruments which has certain chemical cells which are able to see the consumption of oxygen, carbon dioxide, NOx, SOx, which are important from the standpoint of understanding the release of toxic gases, how can we reduce them. And you have the fuel efficiency monitor. I mean, you can see the specific fuel consumption of, for example, DG set, or you have the ferrites for seeing uh, the performance of the flue gases. The methodology, you can understand it, that we can have the ferrite meter for understanding the usage of oxygen and carbon dioxide. So these instruments helps us to measure these parameters which are required for doing the current state mapping. Similarly, we in slide 25, you have again the instruments, the contact type thermometers, infrared thermometers. This has become famous very much these days, as you see it in every plant where people getting checked from a distance through the infrared thermometers for temperatures on the body temperatures. In COVID times, this has come very handy, and this has been one product which has sold like a hotcake. So going on to slide number 26, again, this is different measuring instruments. For example, for the air velocity measuring, you have Pitot tube manometer, you have water flow meter, non-contact type, you have lux meter for understanding the lux levels of what we get in terms of the lighting which is there in the plant through the different lighting equipment, for example, the metal halide lamps or the CFL lamps, etc. So you can measure the lux levels and understand if my lux level is adequate, do I need to go for more or do I need to go for less? Can I do with less? So these are the meters which you can see, and even in slide number 27, when you go ahead, you will see the speed measurements to be taken. For example, if my condenser in the air conditioner, the condenser fan, what RPM is it going through? Do I require to increase the RPM? Or through stroboscope, you have which are the non-contact type meters which tell you about the RPM and RPM of a particular equipment which is performing. And you have the lead detectors, for example, and you have ultrasonic instruments as lead detectors, which, for example, if I have in an air conditioning system, the refrigerant gas getting leaked, so I can detect the leakage through these instruments and understand and try to protect them. Again, this is towards the understanding of the energy requirements. Where is it currently? So having understood what are the meters what we use in conducting the energy audits, we go on to the slide number 28. This is having understood what we've gone through about the energy management, and we have to ultimately we have to see uh, as an example, how do you calculate the compressed air cost? So that we are able to understand what is the financial implication. For example, in this slide, it's been typically shown as if you have a compressor of around 200 horsepower compressor, which normally it would be of 215 horsepower motor, which operates in a year for 6,800 hours annually, and is fully loaded with an efficiency of motor efficiency of 95%. And you all know, I mean, I don't have to tell you guys that compressor works on the principle that it will be, we have a reservoir, you compress the air, put it in the reservoir, and then through the reservoir, we bring this compressed air to the point of usage, and this reservoir acts as a reservoir in the sense that it feeds the point of usage area from time to time, and then compressor again gets loaded on once the reservoir starts coming down. For example, some reservoirs are set at the pressure requirements of the based on the plant pressure requirements between 12 kg to maybe around 6 kg, some at 10 kg, depending on what the requirements are. So you the compressor gets loaded or unloading depending on how the reservoir state of affairs is. Is the reservoir at 6 kg, then it will start again loading again, and then it will run for some time, fill up the reservoir, and then get unloaded because the reservoir is full. So based on that, you try to see that how much time the motor is running. And based on that, when the motor is running at full load, what is the consumption of units, and how many hours it will be on fully loaded condition, and how many hours it will be in the unloaded condition or partially loaded condition. So you calculate the amount of rupees over here required annually, and understand these are the this is what I'm spending money on, the annual energy requirement for my compressed air requirements for the plant. Having understood this is just to give you an idea for the current state. So many a times what happens is that if I can act upon and put it in my, if energy requirements are lesser, should I use a smaller compressor, or should I use a compressor wherein I have a motor which is more efficient in nature? So can I use that? So I can take an investment decision based on my perennial use of compressed air requirements. So to understand this further commercially, we'll go on to slide number 29, which means what are the techno-economical factors which are important from the standpoint of understanding that if we are going to, for example, I've decided that I had previously an inefficient compressor with me, which was bleeding my annual operating costs. So what happens is, what is the investment required for new equipment? You have investments categorized over here in terms of what are the requirements for the equipment, for example, compressor, what are the civil works to be done, instrumentation required, auxiliary equipment required, etc., etc. And on the second vertical, we see that what are the annual operating costs, what are the maintenance costs, manpower required, energy, depreciation of this equipment, etc. And then you see in terms of annual savings, what are the thermal energy savings, electrical energy savings, raw material savings, or waste disposal savings we are getting. So what eventually happens is that net savings are to be seen once you have the annual energy savings calculated from the equipment what you are having understood what is the difference and in between the old and new, what are the annual energy savings, and you subtract the operating costs, and that becomes your net savings. Once you have the net savings and what you have already calculated as an investment, you divide by that and you get the payback period. That means in what amount of time frame you are getting your investment back to you in your pocket. This you will be able to understand with slide number 30. In slide number 30, you see the typical calculations of, this is a very simple calculation being done for example, if I replace the 40 watts fluorescent lamp with a 29 watt CFL lamp. Okay, so what has been done is simple calculations. You understand for the 8 hours usage for 365 days, this is 2920 is the hours what it will run through. If I have 100 lamps, and this will be my total energy consumption of 11680 kilowatts, CFL will have 11 watts advantage. So my um, total energy consumption with replacements of CFL will be 8468, and my savings will be, the difference in energy consumption is 3212 kilowatt. And if I take as rupees 5 per unit, I should be able to save 16,060 rupees. And suppose my investment was 100 rupees a lamp, and 100 lamps, 10,000 rupees. So 10,000 divided by 16,060 is 0.622 years. That means almost half a year, a little more than a half a year, I should be able to get back my investment. Now, having understood this, uh, we go on to the case studies what we have done practically in our plants. So just to take you to slide number 32, we'll go to the energy conservation case studies. Now, if you see this slide, what we have done is we have mapped. Again, this has come through the energy audit. Once you do the energy audit, whether you've done a detailed audit or you have done a targeted audit, you do the energy audit. Once you've done this energy audit, you see we have divided the plant into 7 zones. Each zone being, for example, administration, process plant, breakers plant, machine shop, utilities, coupler assembly, material handling, etc. So once you have divided them into zones, you go through the key equipment of these zones and understand how much are they consuming uh, over there, and then you see the share of these zones. So on the right side, you when you see the share and you understand, if you have to do a quick synopsis, you understand if I should target the two blue category ones, because that will give me around 45% of uh, or 55% of 55% of the total energy consumed is taken by these two zones and these equipments like air conditioner, lighting, heaters, chillers, scrubber unit, and rectifiers, etc. So you can see that if I attack over there, if I don't have time or if I don't have resources, if I don't have money, I can focus upon these two areas and I should be able to attack 55% of my total plant consumption, which was around 421.8 kilowatts. So having understood this, this gives me a snapshot view of what, where and what and how and which equipment I need to look into. Now, this is giving the overall picture. Now, when we move to slide number 33, these are the practical examples what we have done. Now, we'll take one example. For example, this is simple to understand. The before situation is given in the red boxes, what you see. These were the mercury, halogen, and fluorescent light lamps on the red. This was the situation before, and we replaced them with the after situation with the LED lamps, and you can see the difference in lighting also. Okay, now when you do the analysis of this, when you go into the depth, you see in the slide, you will be able to see it. The fluorescent tube lights, the wattage was around 72 watts. And of course, there was a waste of ballast losses were also there, which was around 10 watts. So which means total consumption was around 82 watts. While as in LED, if you see through the luminaries, the wattage used is 40 watts, which means approximately 50% saving is there. And if you can multiply, I mean, if you can multiply it later on with the number of luminaries 151, you will see that it gets multiplied. Similarly, for if you see in terms of fluorescent lamps, from 18 watts, it gets reduced to 9 watts. And metal halide lamps, 250 watts plus 25 as wastage, it gets reduced to 120 watts. So on an average, if you see, if you change, 53% saving is there. Once you have understood that this is the saving, then what is the investment required? You see the investment, if you on the right side, you will see at the bottom, 11 lakhs of investment was required. And what was the annualized saving? It was 4 lakhs. So if you do the simple calculations, the payback period on the left side you will see was 2.75 years, and return on investment was 36%. Now, you can see the annual units which were saved was 60,000, more than 60,000 units. And of course, when you convert 1 unit of electricity saved or 1 unit of energy saved, you also see that how much is the corresponding advantage in terms of less uh, carbon dioxide produced. And if you see it, you also try to save in terms of carbon dioxide emission, and which becomes approximately 50 tons in a year, which is substantial, and it is substantial. And you we just given for an understanding sake that on an average, a mature tree consumes 21.77 kg of carbon dioxide per year. But when you are emitting in tons, you will require uh, hell of a lot of amount of trees to be planted to consume this carbon dioxide. So these are the uh, intangibles what you get with when you save energy and when you do a proper energy management. Similarly, when you go to slide number 34, this we have taken in terms of three projects over here, which you see, wherein you see the before situation for these three projects, and you see the after situation for these three projects. And projects were mainly in terms of, for example, design modification and revamping of chiller plant. We redesigned the chiller mainly because we were using indirect methodology. We were first heating, we were chilling the water, and water was going to the process plant, and it was doing the heat exchange over there. So what we did was, we, instead of using water as a medium, in our process plant, it's a basically an anodizing plant, wherein you would use acid for doing some plating. So what we did was, we straight away took the acid out and chilled the acid through the chiller, and uh, we did away with the water as a medium for heat exchange. So our efficiency got improved from 40% to 85%. So things like that, we need to analyze our systems and understand what can we do to do the better energy management. And similarly, our compressed air requirements, which is the project number 3, we were requiring two set of pressures for two different set of equipments in the plant. So we did away with the one compressor to with a different pressure requirements, which was around 6 kgs, and one different for different equipment, which was requiring 12 kgs of pressure. So that way we did not have to run one system for up to 12 kgs. Uh, Similarly, the project number 2, we employed VFDs for um, goods lift motor and for air compressors. So things like that, when you start analyzing your current state mapping and what can you do in terms of technology and what can you do in terms of improving your efficiency, you get financial benefits. And in this also, you can see we had to do 8 lakhs of investments. The savings were little lesser. We were around 1.67 lakhs. That's why you see the payback period was of 4.8 years. Normally, you try to do all the projects wherein your payback is less than 3 years, and it depends on company to company as well. So you try to do projects less than 3 years payback. But in this case, we wanted to, because we had taken up that we would want to be also the advantage this was giving us was because we were getting a higher productivity through this change in situation. So return on investment 21% lower than expected. Normally you would want to do better than 30%, but in this case we wanted to go ahead with it because of the productivity advantage we were getting it. So having understood this, these are the two projects I've stated over here. Then you can go to slide number 36. These days what you have is you can do online monitoring of your fuel consumption and electricity consumption, and there are softwares available which you can have real-time data available on your laptop or on your machines, wherein you can monitor through the SCADA system how to manage your energy consumption. And these are the in things today in the industrial sector, and wherein you are able to optimally improve your efficiency and consumption of energy. Having understood this, we move on to the last slide, which is the 37th slide, wherein what are the benefits, what are the results. If you see in the slide number 37, you get the results in terms of units of electricity saved, units of cost advantage, what you get in terms of money, uh, the 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 wastage, the allied wastage. For example, we wanted to capture what is the cotton waste we save, what is the weight in terms of carbon dioxide, wood we save in terms of recycling, what is the uh, water consumption we save in terms of kiloliters, fuel consumption, carbon dioxide, hydrogen emissions, and carbon dioxide emissions. So the contribution to the environment is immense. We are not depleting the natural energy resources, what we consume by producing this electricity, which we can save. And as I said, 1 unit of energy less consumed is 1 unit of energy less produced. And so many, you can understand the amount of burden we reduce onto the Mother Earth. So having said that, I've taken you through this journey from understanding what is energy to understanding what is the need of or the government brought in uh, to certain act for energy conservation, and then having understood how do we do the mapping of the current state affairs of our plants, having understood how do we conduct audits, having understood what are the instruments required, having understood that how do we do the financial and technical feasibility and understand the financial results, technical results, and the environmental results by taking up projects which are beneficial both to the environment as well as to the organization. So with that, I conclude my presentations, and I'm open to questions which any of you want to ask me.
Also, this is Rajesh. There was also an incentive scheme started by Bureau of Energy Efficiency several years ago to
Right.
incentivize, companies or organizations which are getting into savings.
Right.
And I think it has lost stream now, or it is still
Uh,
existing.
no, I don't think so. It is still active. It has lost its steam. It's what you can do in terms for your organization is what is predominant right now. And the incentives, I think they are more towards the highly energy consumption industry, like as I said, cement industry is one, or you can say the fertilizer industry, where there is huge amount of energy requirements. Those energy intensive uh, consumption units, they might have some incentives from the government side, but normal average industry like ours does not have much.
Okay, thank you.
Also, very nice presentation, Praveen here.
Thank you
Two
so much.
points.
Yeah.
Uh, Number one, you mentioned about that in the energy auditing, finally, once it is being executed in terms of new equipment or process change, whatever the amount we save versus new amount which is being invested to calculate the payback analysis. But you are saying that we don't normally count the productivity benefit, like because what
Mostly,
productivity improvement has happened.
yeah, mostly. See, what happens is that's where these different audits come into picture. Now, what happens is resources like finance is also not available in abundance, and what again happens is management takes a decision based on their target requirements, what they commit to the board of directors. And in some industries it is mandatory. For example, public limited companies, it's mandatory that you have to have energy conservation measures going on within the manufacturing organization. Say some take a target of 3%, 4%, 6%, depending on what their board allows, and what finances they have available to put money into. So that's why you go into payback and return on investment. So most of the times what I've seen in the board meetings, you go through and you allow maybe certain targeted areas where your return on investment is high, more than 30%, and where your payback is less than 3 years. So you give priority to those areas and take a financial come technical decision. Of course, productivity does not get um, into prime parlance over here, but if the productivity is also there, then this gets an added advantage. Then you might, for example, in our case, where the payback was slightly higher and return on investment was lower. So since we were able to show that our productivity is higher and we need not invest into equipment further, and our space was also a limitation. So combined effect was that we were able to get the investment for this.
Absolutely right. So that's what exactly I was coming to. If you have the productivity part being also taken in the savings, kind of saving, or maybe this thing, then it allows your payback period to be much lower compared to what you have
Absolutely,
been showing.
absolutely. You can what can be done is it can be converted. For example, if
A
we have
financial value can be given to the
yes,
productivity.
yes, correct. You're right. It can be converted into financial numbers and then added on to the savings, which will bring down the ROI and ROI high, higher ROI and lower payback period.
Okay, thank you. And second is that you use this term two times. That one unit saved
Yeah.
is 1 unit of less 1 unit of less
One
unit
unit
produced,
less produced. Correct.
right? But technically, I'm saying if you see, in my understanding, 1 unit of energy saved is 2.5 units of energy produced because you have a lot of losses by the time it comes from
You're
the.
right. You're right. You're right.
So probably that how the people sometimes look at
I
it,
stand, yeah, I got a point. Yes, I mean, in normal parlance, this is what you would say because I didn't consider the losses in between. It was just a pure academic statement from the standpoint of layman. So I didn't take into consideration the efficiency losses which happen between the generation point and to the point of usage. You're right.
what has happened, in Europe earlier, for example, the efficiency of the equipment. I'm talking about specifically for the chill air conditioning equipment, the chillers.
Yeah,
So we used to measure the efficiency in terms of ER, either in terms of kilowatt over kilowatt or kilowatt per
correct,
ton.
correct.
But then over a period of time, they found we should not compare it based on the secondary saving, secondary energy. We should consider it based on the primary energy being saved. So now they've started converting in the regulations itself in Europe that when a manufacturer has to specify the performance of its unit, he has to consider the primary energy. So they are putting a different number, and the regulations are specifying those numbers on the primary energy side. So that the level of changes happened on the Europe side, which is last couple of years.
Okay, I mean, that's an, I mean, I've never been into that area. Since you've been interacting with Europe more, I've been only in Indian horizon, so no idea on that. But it's an information for me, good information to have. And also, what happens is that as we go through in the Bureau of Energy Efficiency, they have been every year improving the target and telling the manufacturers that your ratio has to improve. For example, when they started off with 2.7, then it has moved up to more than 3.5, 3.7 in terms of rating, star ratings, what they give to the equipment, and it is given by the manufacturer themselves. So yes, improvements happen uh, everywhere, and I second to this because important aspect is where you generate. It's important that there you should be focusing more, and also on downstream you have to focus on the side of it also, because once you generate and the loss happening downstream, it's waste for everyone. So I would be of the opinion both sides. One has to concentrate at the point of generation, also at the point of consumption. Also, we need to understand because what happens downstream, we have to understand that as well. So it's a viewpoint. It's a
No,
viewpoint.
it's required both sides. You are absolutely right. It just, just to sensitize the audience sometime that one unit of saving is roughly around 2.5 in a energy efficient production, generation and distribution. But
Correct.
probably in countries like India, the distribution may be further lower.
It
So the
will be
efficiency
further
might
lower.
be,
Yeah,
it might be
you're
1:3 probably.
it could be 1:3. You're right.
Yeah.
It's this thing from next. I mean, next time when I'm presenting, I'll make it 1:3.
Thank you, sir. Very nice presentation once again.
Thank you.
Any other question from participant side?
Thank you, Kaul sir.
Thank you, Vishal.
Thank you, Kaul sahab. Excellent presentation.
Thank you, Rajesh.
Thank you, Kaul Saab. Thank you, Dr. Nikhil.
Thank you, Dr. Anil.
Thank you, Kaul sahab. Thank you very much.
Thank you, Dr. Nikhil.
Thank you, sir.
Thank you.
Thank you, Dr. Nikhil. Thank you. Bye.
Thank you. That's it.
So thankful to Anil Kaulji for being with us and enlightening us with his valuable talk. Thank you, sir.
Thank you.
Thank you, Kaul.
Thank you.
Have a great evening. Bye.
Bye bye.
Thank you, you too.